Another technical issue related to the structure of a test of hypothesis is to decide exactly what it is that we're looking at. What do I mean by that? Well, in some situation, what we're looking at is a single sample and we're comparing that to a predetermined value. So you can think of this one as a single person who gets on a scale to find out if their weight has actually gone below a certain number. Okay, so the number is predetermined, and what you're doing is you're only checking if what you've obtained is below that number. Of course, in statistical sense, we wouldn't be looking at a single person. That's just a little analogy. So in this case, we are calling this a one sample test for obvious reason. We're only considering one sample, we're not splitting it, we're just comparing that to a single number. For instance, in our regular example, we may ask, is it true that the mean heart rate for nursing students after doing jumping jacks is more than 70 beats per minute? Okay, so we're comparing the one sample of everybody who's done jumping jacks to this predetermined number of 70 beats per minute. Okay. On the other hand, we may have situation where we are actually comparing two samples. We want to know if one of the two samples is actually bigger than the other. Well, in this case, of course, we're going to talk about a two sample test. Going back to our example, we may ask, is it true that the mean heart rate after jumping jacks is bigger than the mean heart rate after knee bends? Okay, so this would be a one-sided two sample test. There is one situation that can be a little bit tricky, and it's a situation that you're going to find can confuse quite a few people, and you're going to find probably some research articles you will see have this issue not very clearly figured out. And the situation is the same. Let's say then we do have a comparison of two data sets, okay, or two samples. So we may think that we're in a two sample situation. However, in a two sample situation, we are actually assuming that two samples are separate from each other. It's one sample here, one sample there, no connection between the two. But that's not always true. In some situations, we have two samples, one sample where we are selecting certain people or we're having certain people do some kind of activity, and another sample where we're selecting another set of people who are, however, related to the first set one by one. So in other words, there is a one by one matching of each person or each event in one sample to one event in the other sample. So in this situation, then we call this a paired or a matched test. And these kind of tests are done differently than when the two samples are totally separate. Okay? Why are they done differently, and how are they done differently? In this situation, what we're really interested in is not so much the two sets separate, but the pairs consisting of one person, one subject, one element in one sample with the other one. And what we really need to test are the pairwise differences in the values that we obtain. Okay? So it is really a one sample test, but even though it started as a two samples. So we start with two samples, but we're matching them. For every pair, we're looking at the difference between the two people or the two subjects in the sample, and therefore we end up with just one sample of paired differences. So again, in this one, it can be a bit tricky because some people may not realize that they're not dealing with a two sample situation but with a match situation. So they will be using techniques which are appropriate for a two sample test, but not the technique that are actually required by the matched sample situation. As an example here, what we can do is instead of comparing two groups of people, one of which is doing jumping jacks and the other group is doing the knee bends, what we can do is we can ask the same people to do jumping jacks, then rest, then do knee bends, and then get their heart rates after each one of the two exercises, and then look at their difference. If the jumping jacks and knee bends were actually giving the same mean heart rate, then of course that mean difference would be zero. Some people will be higher in one, some people will be higher in the other. On average, you would get zero. Okay? But on the other hand, if jumping jacks are more strenuous, those differences will tend to be positive. Okay? So again, it's not the two separate groups that we're testing, but it's the one group where we're looking at the difference between the two values.